Hello, and welcome to Chapter 10, Experimental Research. I hope you are just as excited about learning about experimental research as we are about teaching it. My name is Crystal. Joining me will be Vanessa and Hannah. Well, unfortunately, Hannah is a little under the weather, so she won't be joining us today. But we will continue to pray her strength in the Lord. Let's get started. Steps in experimental research. As with any research, before you can begin, you must first lay the foundation. So we will begin with the steps in experimental research. First, you must select and define a problem, select the participants and the measuring instruments. Then you must prepare a research plan, execute the procedures, analyze the data, and then we must formulate conclusions. So, what is experimental research? Experimental research is when the researcher manipulates at least one independent variable while controlling other relevant variables and observes the effect on one or more dependent variables. Basically, in experimental research, the researcher basically gets to control everything. The researcher has control over the selection. The researcher has control over assignment groups. The researcher also has control over the allocation treatment of groups. The researcher controls extraneous variables. And then lastly, the researcher also gets to measure the effect of the treatment. Now we will talk about the methodology of experimental research. First, we must understand the comparison types of experimental research. Experimental research involves comparison of two groups, although not limited to the only two, because some experimental research methods do offer the comparison within one group, and some even offer it with 3 or more groups. So here we'll talk about those different types of comparisons. For the comparison of two different approaches, we'll say that this one is A versus B. Oftentimes we hear this one as the boys versus the girls. We've all played the game where we do boys versus girls. Those are experimental. Who's going to win? Who can tug the war? Who can win the tug of war? Boys versus girls. Then we have the comparison of a new approach and the existing approach. This one is A versus no A. So if we were watering a plant or doing something of the sort, we could say water versus no water. Then we have the comparison of different amounts of a single approach. A little of A versus a lot of A. If we give a plant a lot of sun, then it'll do this. If we give a plant a little bit of sun, then it'll do this. Okay? So now we'll talk about the variables in experimental research. So the independent variable in experimental research is the variable that the researcher manipulates. Manipulate means to change. This variable, the independent variable, has a direct effect on the dependent variable. What is the dependent variable? The dependent variable is the variable that the researcher measures. This variable is the outcome or the result of the study. You should note that nothing should be different between the two groups except the things that you're experimenting on. So basically, understanding experimental research, you must understand that the independent variable influences change in the dependent variable. Independent versus dependent variable. So here we have an example. If I change the amount of water a plant receives, the height of the plant will change. So here, as you can see, the water has become my independent variable because if you remember, the independent variable is something that changes. So the water is changing, the amount of water is changing, so this makes it my independent variable. The height of the plant is the dependent variable. Dependent variable is what the outcome is. So the height of the plant will change depending upon the amount of water that it receives. Dependent variable. What differentiates experimental research from other types of research? First, you must know that experimental research is the most structured research. A well-conducted experimental research study will show the soundest evidence concerning cause-effect relations. Also, the manipulation of the independent variable. This permits predictions, like if you approach X, you will probably get different results than if you will use approach Y. Some other key differences in experimental research are that the experimental research is guided by at least one hypothesis that states an expected causal relation between two variables. Then also you have the experiment group versus the controlled group. These are the types of groups. These are just other names for the groups that are used when you are picking your sample selection. We'll talk about that later in the chapter. Then also the use of randomly formed treatment groups is a unique characteristic of experimental research. When do we use experimental research? Experimental research is often used when we are doing experiments, basically. If we want to know if the children learned throughout a session, then we could use the pre-test, post-test only design group. But this is when we give the kids a test, and then after we've taught the lesson, we give them another test. So this is the pre-test, the post-test, to see how much was learned, if this experiment worked, if this method worked. Then we have the post-test only, where we don't know where they begin, but we know the outcome because we've tested them. Then we offer things like the Solomon 4 group design, factorial, randomized block, and the crossover method. These are just a few of experimental research methods that you could use. So here I show you an example of the experimental design. This design dictates a great extent the specific procedure of a study. So understanding design, you must understand that there are two major classes of experimental designs: a single variable design and factorial designs. When picking a research method, these designs will help understand the procedures and the conclusions if you choose experimental research. These design groups will be talked about later in the chapter. Next, we will talk about how the research questions and hypotheses of experimental research will be stated. Vanessa and myself will take turns discussing these.
Developing research questions. The question is, what is the relationship between the variables which are being studied? Design your research question so that it relates to the research problems, and the questions are based on the problems, therefore they make the research problems measurable and practicable. They give the researcher an action plan. Oops.
So here we have when you're stating a hypothesis. A hypothesis is a researcher's prediction of the research findings, a statement of the researcher's expectations about the relations among the variables in the research problems. This was taken from our textbook. Instead of proving a hypothesis, researchers collect data and analyze information. The results either support the hypothesis or they don't.
The guidelines are that it should be based on previous theory or previous research and build on the theoretical foundations. It should supply an explanation for the predicted results. It should explain the relationship between the variables and try to make the variables testable and measurable. And the hypothesis should be measurable, and testable and measurable is a standard to check whether the hypothesis is well-defined or not.
So here we'll talk about the different types of hypothesis. So here we talk about first the inductive hypothesis. This one is a generalization made from a number of observations. Then a deductive hypothesis. This one is derived from theory and it's aimed at providing evidence that supports, expands, and contradicts aspects of a given theory.
A non-directional hypothesis explains simply what the relationships and differences between variables are. A directional hypothesis provides a predicted direction, and a null hypothesis states that there is no relationship or difference between variables.
So here we talk about non-directional hypothesis and directional hypothesis a little more in depth. The non-directional hypothesis predicts relationships and differences between research objects. The directional hypothesis predicts not only the relationships and differences, but also directions. The directional hypothesis should be stated only if you have a basis for believing that the result will occur in the stated directions.
The null hypothesis is used in a situation when you have little theoretical support or not very much research has been done. Most studies should not be based on a null hypothesis. So an example of the questions would be, for a non-directional question, are stress and health related? For a directional question, are stress and health inversely related? And your hypothesis for those questions would be, I predict that stress and health are related for a non-directional hypothesis, and a directional hypothesis would be, I predict that stress and health are inversely related so that health decreases as stress increases. Now we're going to talk about the methods section of your experimental research. In the picture there you have the mouse saying, it's a rather interesting phenomenon. Every time I press this lever, that postgraduate breathes a sigh of relief. So here we have a cartoon which kind of explains that in a research project, you have to be careful what is actually doing the controlling and who's and why things happen. You know, it may not be the reason why you think things are happening. For sample selection, they should be large and they should be representative of the entire population. The researcher will control the selection of the participants, select them randomly, and assign them to your two groups, experimental or control, randomly. The experimental group will get the new thing that you're looking at. The control group will get the old or the traditional thing. Everything else should remain the same. For your instruments, they can be pre-prepared off the internet, or they can be made by the researcher. You have to provide information on the reliability and the validity. So this could come from the book on measurements, or you could do your own t-test or p-test for reliability and validity. You can use more than one instrument, and often in this research, you will do a pre-test and a post-test. Your strategy or your design will be like a standard scientific experiment. So for an example, which reading method, textbook, classroom arrangement, style of teaching is better? X versus Y. So in languages, people have found out that if you use a picture when you teach vocabulary, students learn a lot more. So that would be X. When you do the experiment, would be X would be using a picture, Y would be not using a picture, and you're trying to guess which of the groups is learning the most, or you're trying to scientifically find out which group is learning the most. Second example of a design is it better to use or not use, or do or not do something? X versus no X. So studies have shown that if you read a poem before class starts, that students are better behaved. So that would be an example of X, which is reading the poem, versus no X. No X is the control group, where you just start your class in a traditional way. A third design strategy is for X versus more X. So does more reading, math, prayer, or fun time in a classroom make a difference? Nothing should be different between the two groups except the thing you're experimenting on. Your independent variable is also called your treatment, causal, or experimental variable. That's what you're changing. You're changing the method of instruction, the length of the treatment, whether or not you do something or not. Your dependent variable is your criterion, effect, or post-test variable, and that's what you're watching. So did the students do better with X or Y, with X or without X, or with X or with more X? And then how much better or worse did they do? So you can add that into your research. The procedure is similar to the procedures for most research projects. You need a detailed description of what you'll do. You start with how you select the sample, whether or not you do a pre-test, how you're going to get to the site, how you're going to collect the data. It's going to be forms or surveys, and how you will store the data, being careful to store them, keeping everybody's confidentiality intact. The thing you need to look out for when you do your procedure is your assumptions and your limitations. So when you do a research group, you need to be careful that there are things that you think are true, but you don't know for sure. So for example, you may assume that none of the students has a lot of background in what you are researching. So if you randomly went into a school and chose a bunch of students and randomly assigned them to groups, you might assume that none of them, if you're doing a language research project, that none of them come from a family where they already speak the language fluently. If you make that assumption, then your results will be skewed if there are people in the group who speak the language fluently at home. So you have to be careful about what assumptions you're making, and you can write that up in your conclusion, in your analysis of your data. Another thing is the limitations, things you cannot control, but might be a problem for your study. For example, if you couldn't find enough students or you didn't have access to them for a long enough time to do everything that you wanted to do. So that's another thing that you should write up when you do your proposal. Some examples of research that's been done in languages. Studies show that students retain more vocabulary in language when pictorial representations are used. Studies show that students work harder when they've done a self-assessment in the middle of the unit. Studies show that students are more engaged when teachers use a variety of teaching resources. And then studies show that teachers who have 2 planning periods per day have fewer absences for work, and their students' grades are 1 grade higher. So the last one is just something that I think people would be really interesting to study, but that's not actually ever been done. So I'm going to give you an example of a factorial design. That's when you are measuring more than one thing in your experiment. So for example, if you have a new method of teaching French, is this method better? You're going to have group 1 and group 2. Does the vocabulary improve and how much in the new method, and how much does the vocabulary improve with a traditional method of teaching, and then does the sentence structure improve? So you're looking at 2 things, vocabulary and sentence structure. So you actually have four different things that you're looking at, 4 different groups. Or you can also look at, can students write more or longer with the new method of teaching French? So then you have 6 different things that you're looking at. And you can actually, I read one research paper where they actually looked at about 20 different aspects of writing when they did their research paper. So that's called a factorial design, because you're looking at, you get more results than you would otherwise. Experimental research is the gold standard of research methods because the results are generalizable if the research is well done. Your conclusions will be numbers, and they'll give you valid and valuable information, which will help you in your teaching and your administration. You will have to also discuss threats to internal and external validity. Threats to internal validity are things that might go wrong with the data. Also, students may change for other reasons than your variable, or some people may drop out. So for example, if you're doing a study on languages and it happens to be at the same time they have a French exchange program at your school, then that's a threat to the validity of your results, because you've got a lot of people around speaking French all the time, so you can't measure accurately how much of the change in the students was what you did in your teaching versus what happened because of a lot of people around speaking French. Threats to external validity are doing a pretest. If they are pre-tested, then they might react differently to the study. The control and experimental groups might discuss what's going on with each other. That's called treatment diffusion, and that affects the validity of your results. And the Hawthorne effect, which are when participants act differently because they know they're being studied, so they might try harder or they might be more alert. So there are just 3 examples of external validity that you have to discuss when you write up your proposal. You have to show that you have tried to control the threats to validity. In this cartoon, it says 99% of people surveyed were lonely and wanted someone to talk to. And the responding penguin says, duh, yeah, they're the only people who respond to telephone surveys. So everybody else who's not lonely and has too many people to talk to, someone's going to call them for a survey, they're going to hang up or say they can't talk right now. So that will affect the validity of the results. And one thing I want to talk about just before we end is the overall methodology and how experimental research differs from other types of research, for example, ethnographic or causal comparative. In your sample selection, as we've already said, experimental research is random. Ethnographic will choose a particular group, so it's kind of the opposite of random. And then causal comparative will choose two different groups already formed, which are representative of their own population. For data collection, experimental is numbers-oriented. Ethnographic is interviews, observations, and field notes. And causal comparative, the data collection will usually use the mean and a t-test. In your conclusion, we've already talked about that, so if you go over the slides, you'll find out what the experimental conclusions are like. The ethnographic conclusion is going to be a narrative, which shows the themes which you noticed. And then your causal comparative is similar to experimental, but you have to be very careful to identify the cause and effect because the groups weren't random. So enjoy your experimental research.